Okay, so this is the our tutorial for multiple linear regression. So please download the corresponding R script as well as the PDF for the tutorial as you follow along. So one thing I'll say is this tutorial, as you're looking at it, you probably will realize it looks very similar to what you've seen in the past three, and truth be told, it is. Right? There's just some minor differences with multiple linear regression. So I'm going to read in the data first. So the file is called delivery.txt. I'm going to just read that in and attach it. And I've always say it's a good idea to always just have an idea about what your data set looks like, whether the variables are categorical, quantitative, how many observations you have. So in this example, the response variable is the delivery time, and the predictors could be the number of product that the delivery person has to deliver, as well as the walking distance by the deliverer. So we're going to fit a multiple linear regression model. So to do that, we're still using the LM function, your response variable tilde, and for your predictors, you're just going to append a plus sign in between your predictors. So that's just what we need to do to run it, and we can type our summary of our linear model as well to see the estimated intercept and the estimated coefficient for each predictor. So in this case, the slope for the first predictor is 1.61 and the slope for the second predictor is 0.014. And we can kind of look at the p-values to see whether these should be left in the model or not. So pretty much similar. I think I mentioned this in one of the earlier tutorials, but let's say you want to find the critical value of, say, the F statistic, right? So our F statistic was 261.2, and R provides this p-value over here. But in some of the later things that you'll be looking at, R will not provide the p-value for you. It'll provide the F statistic, and then you have to see whether to reject or fail to reject the null hypothesis. So to find the critical value for an F distribution, so an F distribution is always specified by some people call this the first degree of freedom, or DF1. Some people call this the second degree of freedom, or DF2. Some people even call it the numerator and denominator degree of freedom. So the first degree of freedom is in an ANOVA test for a multiple linear regression model. The first one is the number of predictors. The second one is the number of observations you have minus the number of predictors, as well as minus the slope, right? So it's going to be 25. You have 25 data points minus 3. So to find the critical value, you're going to put in 0.95. So at significance level 5%, you need to put in 0.95, basically 1 minus the significance level, and then the first and second degree of freedom. So this tells me that the critical value for this F test is 3.44. So if our F statistic is bigger than that, we will reject the null because the p-value will be smaller than your significance level. So as I say, in this example, the p-value is given, so you might wonder, why do we need this? But later on, the p-value will not be provided in some of the later tests that we'll do. So to find the confidence intervals, same thing as before with simple linear regression. We're using the conf_int function, your linear model, as well as whatever confidence level you want at 95%. So that's the lower and upper bound of your intervals. Some other things that we could do, right, is to find the confidence interval for the mean response and the prediction interval for a response for specific values of the predictors. So that's something we did in simple linear regression. In this case, right, similar thing. Now we just have two predictors whose values we need to specify. So this is specified using data.frame, and we can easily find the intervals that we need, right, and the lower and upper bounds given to us for both the confidence interval for the mean response as well as the prediction interval for a single response. So if you kind of compare what you see over here with the past few tutorials, you probably realize very similar. So I'm going to kind of just pose this to you, right? If you look at the tutorial for how you produce the different scatter plots or residual plots, ACF plots or QQ plots, to assess the whether the regression assumptions are met, how will you do it in this setting with multiple linear regression? I'm going to just leave that for you to kind of maybe figure out on your own. Right, feel free to refer to that tutorial. One thing I'll say, right, in multiple linear regression, the scatter plot of the response and the predictor is probably not so useful because you have multiple predictors, so you might be saying, which predictor do I want? So in a multiple linear regression setting, the scatter plot is not so useful. What you want is the residual plot that you'll be working with extensively.